To one and all, welcome to sisyaclass. ఈ రోజు మనం నేర్చుకోబోయే టాపిక్ ఇంక్రీజింగ్ అండ్ డిక్రీజింగ్ ఫంక్షన్. ఓకే, వెల్కమ్ టు ద మ్యాథమెటిక్స్ సిరీస్ ఆఫ్ sisyaclass. ఇప్పటి వరకు మనం క్యాల్కులస్, దానికి ముందు ట్రిగ్నోమెట్రిక్ ఫంక్షన్స్ గురించి డిస్కస్ చేసుకున్నాం. ఆల్సో ఆన్ యూట్యూబ్ మీకు ఆల్రెడీ కెమిస్ట్రీ లైవ్ కంటెంట్ కూడా అవైలబుల్ ఉంది. సో రైట్ నౌ మీరు సబ్స్క్రైబ్ చేసుకోకపోతే ప్లీజ్ సబ్స్క్రైబ్ చేసుకోండి అండ్ ప్లీజ్ డూ ఫాలో అస్. And today's topic in the sequence of chapters we are learning, that is increasing and decreasing function. Now, idi applications of derivatives lo oka part. Ee roju podduna class we have discussed about rate of change of quantities. So consequently we are also learning about increasing and decreasing function. Tarvata rep madhyanam vachesi we will be learning on the tangents and normals. Okay, so this is how the process goes, and tarvata we will be having the consequent lectures on the calculus. So I would like to briefly introduce about myself. My name is Sai Satish. I have done my masters from IIT Palakkad. I've trained over 5 years for over 50,000 students. Right. Okay, the first topic vachi increasing and decreasing function. Okay, we'll try to just more analyze in analytical sense. Okay, oka graph తీసుకున్నప్పుడు when can we say the function is increasing? Okay, so let's take a graph where the function is just increasing. Ante with respect to the x-axis, right, the values are always greater. Okay, ante entante ippudu nenu oka value తీసుకున్నాను x1 ఒకటి x2 ఒకటి. Okay, now here clearly when you are moving from the left hand side to the right hand side, here x1 is greater than x2. Don't you think the graph is just increasing, right? It is just blowing up to infinity, right? Now when you are moving from the values from the left hand side to right hand side, for the values of x1 greater than x2, ఇప్పుడు నేను ఏం చేస్తానంటే ఇక్కడ I would like to take f of x1. సో ఇది somewhere ఒక వాల్యూ, సిమిలర్ గా f of x2. సో ఇది కూడా somewhere ఒక వాల్యూ. So among f of x1 and f of x2, which value is greater? ఈ రెండిటి వాల్యూ మధ్యలో which value is greater? You can clearly see that f of x1 is greater than f of x2, right? So this is nothing but a monotonically increasing function. Okay, for any two values which are like ordered like x1 greater than x2, consequently if I can come up with an inequality that is greater than or equal to such that f of x1 equals to greater than or equal to f of x2, then if it obeys for each and every point, okay, then we can say that it is monotonically increasing function. Then we can say that it is monotonically increasing function. One such direct example is y is equals to e power x, right? This is monotonically increasing function, right? This exactly looks as an extension of this graph itself. This is y is equals to e power x graph. Similarly, y is equals to x graph. Now, how it is related? Like, you know, ఇది సాధారణంగా it becomes a very abstract sense that x1 greater than x2, f of x1 is greater than or equal to f of x2. This becomes very obvious for when we have a graph. Okay, మనకి graph available ఉన్నప్పుడు seeing a graph we can come up with this conclusion. But when he asked a very random or a very complicated function, now it is very hard for you to even plot a graph. Forget about like whether we can conclude or acknowledge adi increasing function or decreasing function. That's a later thing that comes under a later discussion. But right now, without even visualizing how the graph is, but are we in a position to say that is this an increasing function or decreasing function? Now there comes the beauty of calculus, right? So here we will try to just analyze how this graph acts in terms of calculus, right? So ఇప్పుడు మనం ఏం నేర్చుకున్నాం, ప్రతి ఒక్క పాయింట్ దగ్గర we know that we can draw a tangent, right? So now if the function is increasing, can you see this graph? Can you see the tangents at each and every point, right? If I try to plot the tangents at each and every point, right? So these tangents are always, if you see, the angle is always greater, right? It is not about greater, the slope is always positive. That is what I meant to say, right? The slope is always positive. So if you try to take this, all these angles lie between 0 to 90. In 0 to 90, the tan theta value is always positive, and hence you can say that so tan theta value is always positive. So you can say that it is always, slope is always positive, or it is equal to 0 when it is actually parallel to x-axis, right? So this is how you can find, whenever you can also conclude that if f dash of x at each and every point, if it is greater than or equal to 0, you can say that it is monotonically increasing function, right? Monotonically increasing function. So this inequality should be satisfied for each and every point in order to say that it is a increasing function, right? But if some cases, so one of the contradictory example is, let's take for example sin x. Okay, ఈ గ్రాఫ్ మటుకు మీరు చూస్తే, so from 0 to pi by 2, 0 to pi by 2, the graph is monotonically increasing. From pi by 2 to pi, again it is monotonically decreasing, right? So this is on whole this graph from, if you take the entire domain of sin x is neither increasing nor decreasing function, right? So this is one of the contradictory example of which is neither increasing nor decreasing function, right? If y is equals to e power x is one such example, even y is equals to, but if we are trying to confine the domain, right? If we are specifically talking about what about the function that I have defined sin x right from the domain of 0 to pi by 2, okay? I have taken the universal set itself as 0 to pi by 2, and now if I try to analyze, then I can say that sin x is a increasing function, right? Strictly increasing function, in fact, like if I take the open interval. But whenever I try to put this equality sign, then it becomes the monotonically increasing. Monotonically and strictly ki difference ఏంటంటే, strictly increasing function లో equal to sign అనేది ఉండదు. అంటే ప్రతి ఒక్క వాల్యూ exact, definitely it is greater than the other value, the value that is adjacent to it, right? So that is what the difference between monotonically increasing and strictly increasing. So just for the sake of reference, ఒకసారి చూడండి, if f dash of x at each and every point within the domain that has been specified, if it is greater than 0, then we can conclude that this is monotonically, or this we can say that strictly increasing function, right? We can say that this is strictly increasing function, right? So, and if we say that f dash of x is greater than or equal to 0, we can say that this is monotonically increasing function, right? So there might be some chances where, for example, if I take some random curve, right? So if you see here the curve, though it is increasing, but at some point you can see that the slope is equal to 0, right? You can see that the slope is equals to 0. That means if you try to draw a tangent at that point where that line will be parallel to x-axis, right? But if you see the whole graph, there is always a tangent that is always in the positive sense. That is f dash of x is always greater than or equal to 0. But this is one way we called it as a first derivative test. But in the later case also, we can also study something called double derivative test. Now that's even more beautiful to understand, but it is little more twisted and turned. So we'll just learn in some time. So this is nothing but monotonically increasing function and strictly increasing function, right? In the similar way, you can also guess how does the decreasing function look like. Okay, I would like to explain you how does a strictly decreasing function look like. So okavela gaani oka graph teeskoni, so I have taken a graph. So let's take a graph like this. Okay, so if you see here, and if I take any two values on the x-axis, x1 and x2, where x1 is greater than x2, right? Now if I try to just see what are the consequent functional values for this x1 and x2 for the graph which is decreasing, right? Which is in the decreasing pattern, right? ఇప్పుడు నేను చూస్తే f of x1 and if I try to see f of x2, ఈ రెండిట్లో ఏది పెద్దది? f of x1 and f of x2, which one is greater value? So if we see here, f of x1 is greater than f of x2, right? F of x1 is greater than f of x2. So for the values of x1, sorry, here there's a small thing. Here for the values of x1 less than x2, f of x1 is greater than f of x2. So that is the first thing. Okay, so this is the consequence for strictly decreasing function. But if we have to say monotonically decreasing function, then we can just keep the equality sign. Similarly, we can take one more note point here. If f dash of x is less than or equal to 0, then we can say it is monotonically decreasing function. But if it is strictly f dash of x is less than 0, we can say this sort of a case as strictly decreasing function. Okay, strictly decreasing function. Okay, right. అంటే ఒకవేళ కానీ ఇలాంటి pairs మనము ప్రతి ఒక్క పాయింట్ దగ్గర ప్రూవ్ చేస్తే దట్ ఈస్ ఇన్ఫాక్ట్ ప్రూవింగ్ దిస్ వే ఓన్లీ, రైట్? హౌ కెన్ వి యూజ్ ద క్యాల్కులస్ ఇస్ యూజింగ్ దిస్ టెక్నిక్, ఆర్ ఎల్స్ లైక్ ఇట్ టేక్స్ ఈవెన్ ద decades to find whether the function is increasing or decreasing. By just using this sort of a calculus we can just find whether the function is increasing or decreasing. Now I would like to explain you one more technique, that is the second derivative test. Let's try to just completely do the postmortem of this graph by second derivative test. ఇప్పుడు ఏం చేద్దామంటే ఒక గ్రాఫ్ తీసుకున్నాను. లెట్స్ టేక్ దిస్ సార్ట్ ఆఫ్ ఏ గ్రాఫ్. ఓకే, పాయింట్ ఏ, పాయింట్ బి, పాయింట్ సి. వెయిట్, లెట్స్ టేక్ ఓకే సి. Okay, now let's take point A, point B, point C, point D and point E. Now in this whole graph okavela meer chuste from point A to point B, okay, the function is increasing. In fact I can say that f dash of x is positive, right? You can say greater than 0. From point B to point C, if you see here, from point B to point C, f dash of x is less than 0, right? Now from point C to point D, right, so this point again f dash of x is still less than 0. From point D to point T, from this point to this point, so this graph here, f dash of x is greater than 0, right? But here one corollary, or you can say one consequence is small, like you can take it as a small note point. Here if you see, there is one peak, that is crest and trough of a curve అని అంటారు కదా in terms of a graph. Here you can see there is one pinnacle of this point, right? This point, okay, this point is called the maxima, okay, and this point is called the minima. Ikkada meer chuste, if I try to take the tangents at each and every point, right, so what is happening to this tangents? Ikkada positive, 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 positive 0, and again negative, negative, negative. But if I try to see the rate of the change of these tangents, how they are, see here, if you see, suppose let's try to analyze the angles. Okay, ikkada 45 degrees ఉంది అనుకోండి ఫర్ ఎగ్జాంపుల్, ఇక్కడ 30, ఇక్కడ 20, ఇక్కడ 0, మళ్ళీ ఇక్కడ ఏమైపోతుంది, ఇక్కడ నెగటివ్ లోకి వెళ్తుంది. ఓకే, నెగటివ్ again, it is becoming slowly, like for example -10, -20, -30, -40, right? ఇక్కడ మీరు చూస్తే ఫ్రమ్ ద స్టార్టింగ్ ఇక్కడ 45 ఉంది, తర్వాత 30, 35, 25, 10, 0, -10, -20, -30. If you see here, the rate at which these angles are shifting, that the angles are changing, is actually decreasing. Yeah? So I just want to write whatever is there in my brain. I am just saying the rate of change of slope, the rate of change of slope is actually decreasing, right? It is actually decreasing. This is what I wanted to slide. It is actually decreasing. The rate of change of slope is actually decreasing. Ante entante, the double derivative is actually, in fact I can say the rate of change of slope ante, rate of change is nothing but f dash of x. Rate of change of slope ante f double dash of x is less than 0. At whole of this points, I can say f double dash of x is less than 0. Now, malli ikkada if we try to analyze, suppose here if you see, the negative angle is decreasing, right? The negative angle is decreasing over a period of time. See, here the negative angle is slowly decreasing. Again it is becoming equal to 0, and again it is what is happening? The angle is strictly again increasing. If you see, the negative angle is increasing, and as well as that means this negative inclination is slowly increasing. That means the slope is started to increase, it became equal to 0. From 0 again it is becoming positive. So if you see this sort of a dissection completely, here if you can see, the f double derivative is greater than or equal to 0, right? So these points are called critical points. వీటిని ఏమంటాడు? Critical points అంటాడు. Okay, if wherever the first derivative is equal to 0, we call those points as the critical points. Or there is one more fellow which is hiding in all these points, right? Though that is nothing but this point C. This point C is called the point of inflection. చూడండి, ఇక్కడ డబుల్ డెరివేటివ్ వచ్చేసి లెస్ దాన్ 0, ఇక్కడ డబుల్ డెరివేటివ్ వచ్చేసి గ్రేటర్ దాన్ 0, బట్ దేర్ వుడ్ బి ఎ పాయింట్ వేర్ ద డబుల్ డెరివేటివ్ వుడ్ బి ఎగ్జాక్ట్లీ ఈక్వల్ టు 0. దట్ పాయింట్ ఇస్ కాల్డ్ ది పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్. వాట్ ఇట్ ఇస్ కాల్డ్? point of inflection, right? Now this is also treated as a critical point, but this point is neither the maxima or the minima, right? So this we can apply even in the 3D coordinate system as well as in n-dimensional planes in order to analyze whether the point is the maxima or the minima. Also we can have further promote our discussion about the local maxima, local minima, global maxima, global minima in the future classes, right? As of now I'm not just floating away or diverting our discussion into that state. Right now we have, let's confine like what is meant by the increasing and decreasing function, right? So double derivative test does not even acknowledge whether the function is increasing or not, because whether the function is decreasing or not, but it can just attribute a character, that is whether this is whatever the critical point is there, is it a maxima or a minima. Okay, so this is all the whole thing. So final conclusion ఏంటంటే whenever we have f dash of x is greater than or equal to 0, then it's increasing function. Whenever f dash of x is less than or equal to 0, that's a decreasing function. Strictly అంటే it will be strictly greater than 0. That's all we have. Now let's move on to the examples. Still I have one more thing to just I just wanted to say you all, even though it is little outside the context, but I just wanted to say this. Okay, quadratic equation, that's a parabola. If I'm saying a quadratic equation is greater than 0, okay, and greater than 0 annappudu, two note points you need to highlight. So whenever you have x minus alpha into x minus beta greater than or equal to 0, that means x belongs to minus infinity comma alpha union beta comma infinity. Okay, here I should mention that alpha is greater than beta. Okay, one more note point to be taken, x minus alpha into x minus beta is less than or equal to 0. This implies that x belongs to alpha comma beta. ఈ రెండు నోట్ పాయింట్స్ మీరు నోట్ డౌన్ చేసుకోండి. దిస్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్, రైట్? ఇది కాకుండా ఇన్ ఆర్డర్ టు అనలైజ్ ఎ గ్రాఫ్, ఓకే, whenever we are confronting a parabola, the parabolas are of two types. One is the concave up, one is the concave down. Okay, so ఒకటేమో ఇలాంటి పారాబోలా, ఒకటేమో కంప్లీట్లీ ఇట్ ఈస్ ఫేసింగ్ టువర్డ్స్ డౌన్, రైట్? ఈ పారాబోలాకి if you try to see, all the functional values are positive, right? And here if you see, all the functional values are negative, right? And here if you see the discriminant of this sort of a graph, okay, the discriminant is always less than 0, and that means that there is no root that is existing, right? Similar ga ikkada kuda if you see, the discriminant is less than 0. And when can you say the parabola, for example, y is equals to ax square plus bx plus c? Just trying to have this glimpse of parabola, because this will be required in doing some problems. Problem lo will be using this type of characters. Now whenever I have a value greater than 0, eppudaithe a value greater than 0 untundo, that means our parabola is facing upward. Okay, now this is the character. Okay, whenever the a value is less than 0, that means our parabola is facing downward, right? So in both of these cases we will be using this. ఈ ఒక్క నోట్ పాయింట్ కానీ ఈ just try to take down. Okay, when the parabola is facing upward, a will be greater than 0. When we have here a will be less than 0. Specifically, they're talking about those parabolas where it is not even touching the x-axis. The discriminant should be less than 0, and here also the discriminant should be less than 0. So we'll be recurrently using this one. Okay, right. Okay, so if you see the first question, the interval containing the interval real values of x such that f of x equals to root x plus 1 by root x is strictly increasing function. So whenever I say it is strictly increasing function, that means f dash of x is greater than 0, right? So if you try to derive this function, what is the differentiation of root x? That will be 1 by 2 root x plus what is differentiation of root x? So this you can write it as x to the power minus 1 by 2. Right, now this will be minus 1 by 2 x to the power minus 1 by 2 minus 1, that will be 1 by 2 x to the power minus 3 by 2. So you can write it as in the denominator x to the power 3 by 2, x to the power 3 by 2 can be written as x root x greater than 0. Okay, ఇప్పుడు నేను ఏం కామన్ తీసుకోవచ్చు ఈ రెండిట్లో? I can take 1 by 2 root x, I can take common. Okay, so that will be 1 plus 2x greater than 0. Okay, 1 plus 2x 1 plus x greater than 0, right? See, this 1 by 2 root x value is always positive because there is root and this is positive, so this whole value is positive, so this has nothing to do with our case. right? And one more thing is, from here we can always say that the values of x is greater than 0. Okay, now here you see 1 plus 1 by x. So okay, 1 plus 1 by x should be greater than 0, right? So from here I can say that 1 by x is greater than minus 1. So from here I can say that if you try to reciprocal this, x value is less than minus 1. So from here you can just see here the values are from minus infinity. One second, just 1 plus 1 by x is greater than 0. 1 plus 1 by x is greater than 0. So from here I can write x plus 1 by x is greater than 0. From here I can say that x is greater than minus 1. Okay, x is greater than minus 1. So you can just treat here that 1 plus 2 root x plus this, so this will be equal to 0. Okay, x f dash of x is 1 by 2 root x. This will be x to the power minus 1 by 2, 1 by 2 x root x. So 1 by 2 x root x, and you can take 1 by root x common, so that will become x plus 1 by x is greater than 0. So x plus 1 is greater than 0, and here the values of x are, you can never ever take this values to be that is less than 0, because always the values of x is greater than 0. So you can never have this sort of a value minus infinity comma 0 and this. So only value left out is 1 to infinity or 0 to 1. But if you are taking this, so this should be greater than minus 1. So the values are from 0 to 1. Okay, see here you have a function f of x equals to x to the power x. Okay, now apply log on both sides. How do you differentiate? He's saying that for which values of f of x the function decreases. So this will be, so y is equals to x to the power x. So apply log on both sides. Log y is equals to log x power x. So this will become x log x, right? Now you try to differentiate 1 by y into dy by dx is equals to, apply UV rule. U into differentiation of log x will be 1 by x plus, again this will become log x. So the differentiation of this is f dash of x is nothing but, if you take y to that side, it will become x to the power x into 1 plus log x. So this is the direct thing. So function where it decreases ante f dash of x should be less than 0. That means 1 plus log x should be less than 0. So from this I can say that log x is less than minus 1. So x is less than e to the power minus 1. X is less than 1 by e, but as what is the domain of x? X can never be negative. So hence x is less than 1 by e. So the values are from 0 to 1 by e. Okay, the values x belongs to 0 comma 1 by e. Okay, so that is what it is. Okay, so this is very much clear. All right. Okay, next. The set of real values of x for which the real valued function f of x equals to x cube plus 2ax square plus 3 times of a plus 1 into x plus 5 is strictly increasing. Okay, when can you say the function is strictly increasing? Okay, when again f dash of x is greater than or equal to 0, greater than 0. So what is the derivative of this? This is nothing but 3x square plus 4ax plus 3 times of a plus 1. So that will be greater than 0, right? So if you see here, this is again a parabola. But here if you see, what is the value of the coefficient of x square? That is plus 3, which is greater than 0, right? Which is greater than 0. So definitely the parabola will be facing up. Okay, the parabola will be facing up. It will be like this, right? So we have, but definitely if in order to say that it is having no negative value, that means there should be no intersection such that it crosses the x-axis. If it goes below the x-axis, the values will be negative. That means these values will be negative. That means f dash of x will be less than 0. That should not happen. In that case, I'll be taking the discriminant b square minus 4ac, where it should never ever touch the value. So b square minus 4ac is less than 0. So what is b square minus 4ac I have? That is 4a whole square. So I'm just writing here b square minus 4ac is equals to 4a square, that will be 16a square, minus 4 into 3 12, 12 into 3 36, so 36 into a plus 1. Okay, So 16a square minus 36 into a plus 1. So this should be less than 0, right? So what can you take common? You can take 4 common. So this will be 4a square minus 9 times of a plus 1 is less than 0, right? So this will become 4a square minus 9a minus 9, okay? 4a square minus 9a minus 9 is less than 0, okay? So now from here you just take the splitting the middle term, 4a square minus 12a minus plus 3a minus 9 is less than 0. So from here you can take 4a common, so you are left out with a minus 3. This so this is a minus 3, and again this is 9, this is 9, okay? A minus 3, so this will be plus 3. So 4a plus 3 into a minus 3, so this will become a is equals to minus 3 by 4, a is equals to 3. But whenever I said that x minus alpha into x minus beta less than 0, x belongs to minus 3 by 4 comma 3, okay? Minus 3 by 4 comma 3, answer is option B, okay? So a belongs to minus 3 by 4 comma 3. So idini direct indak cheppinatle direct ga whenever we have x minus alpha into x minus beta less than 0, then we can say that x belongs to alpha comma beta, okay? So this is the thing that you need to note down, okay? Next, f of x equals to kx cube minus 3x square minus 12x plus 8 is strictly decreasing for all x belongs to R. Then what is the value of k? Simple, malli ikkada em antunnadu, it is strictly decreasing function antunnadu. So can I say that f dash of x is less than 0, right? Again, what can I do? 3k x square minus 6x minus 12 is less than 0, right? So 3k x square minus 6x minus 12 is less than or equal to 0. Now again, in order to say that this function is strictly decreasing, so I need to again use this. So again, if you see here, 3k x square, this is always positive and it is facing upward, okay? So it is facing upward, and now if you try to take the value 3k x square, okay, if you try to take b square minus 4ac, what will be b square minus 4ac? Either it might be either positive greater than 0 or it might be something like this, but in either of these cases it should never touch the x-axis. So he's saying in order to say that it is strictly decreasing, it is strictly less than 0, this k value should be negative, okay? The k value should be negative, the 3k value should be less than 0, because in order to sustain this inequality, only this sort of a parabola will satisfy, that is a is less than 0, that is 3k is less than 0. From here we can say that k is less than 0. So from here we need to just remove of this sort of an inequality where the k value is greater than, so this value is false, and if k is greater than minus 4, that time again we'll be having a possibility for all x belongs to R, this might not satisfy. So for every value, in order to have this inequality, so even this option is discarded, but still let's try to analyze by using the b square minus 4ac ingredient, okay? So b square, that will be, so you just take b square minus 4ac is less than 0, so that will be b square minus 4 into 3 12, 12 into 12 144, okay? So b square minus 4ac 144k, okay, is less than 0. So if you try to take 4 common, so that will become so if you can in fact take 9 common, but yeah, let's take 4 9 plus, this will become 4 3s are 12 and 4 6s are 24, okay, less than 0. Again you can take 9 common, so that will become 36 times 1 plus 4 9k, okay? So 1 plus 4k is less than 0. So 1 plus 4k is less than 0. We have 1 plus 4k is less than 0. So from here I got 4k is less than minus 1, k is less than minus 1 by 4. So we got the inequality, right? The k value is less than minus 1 by 4. Okay, so the answer is option A. Simple, ikkada entante eppudaina gaani ilanti case vachinappudu, when he is saying strictly decreasing function, f dash of x should be less than 0, okay? F dash of x should be less than 0. So ee case lo f dash of x is less than 0, but for every value, a value man substitute chesina gaani, you should always be getting less than 0, but that is possible only when 3k is less than 0. Endukante if ax square plus bx plus c, okay, for every value of x, if you see here, there are two conditions under which this will be always strictly greater than 0. First is that should be a should be greater than 0. The next one is there should be discriminant should always be less than 0, right? So that is the only possibility in which the parabola will always be in the positive direction. That is, it will all the values of x, for any values if you substitute, all the values are positive itself. It is in the positive y-axis. But in the other case, when it can be decreasing, that means f dash of x is less than 0 is when ax square plus bx plus c is less than 0. That means a should be less than 0. That time you will be having a parabola that is facing downward, as well as you can always find this inequality, that is a less than 0. What is a over here? 3k. And now discriminant is less than 0, from which I got the option A. Okay, the interval 7 comma infinity f of x equals to mod x minus 5 plus 2 in times mod x minus 7. ఇక్కడ చూడండి, ఇక్కడ 7 నుంచి infinity వరకే అడుగుతున్నాడు. So you don't have to entirely find the split function. Okay, just greater than 7. So for the values of x greater than 7 కంటే greater ఉన్నప్పుడు mod x minus 5, ఇక్కడ breaking points వచ్చేసి 5 ఇంకా 7. So for values of x greater than 5, we have 7 minus 5, which is like it will be greater than 0. Mod x minus 5 will be positive x minus 5, and mod x minus 7, when it is greater than 0, that will be 2 times x minus 7. Okay, so this will become, so మనం ఇక్కడ ఇంకా we can find the breaking values. For example, x less than 5 and 5 is less than x is less than 7, but we are not interested in these values, we are just interested in this value. So this will become x minus 5 plus 2x minus 14. So this will become 2x plus x, 3x minus 19. 3x minus 19. Now if you try to derive this function f dash of x, that will be greater than 0, because if you take the differentiation of this function, this will be 3, which is greater than 0, strictly greater than 0, hence you can say it's an increasing function. So అర్థమైంది కదా, 7 to infinity మధ్యలో ఈ డొమైన్ వాల్యూస్ కి ఈ ఫంక్షనల్ వాల్యూ మటుకు ఇంక్రీజింగ్. పూర్తి డొమైన్ వాల్యూ గురించి వాడు అడగట్లేదు. నాట్ ఫ్రమ్ మైనస్ ఇన్ఫినిటీ టు ప్లస్ ఇన్ఫినిటీ, ఫ్రమ్ ఓపెన్ ఇంటర్వెల్ 7 comma infinity, this functional value I have just confined our discussion just on x greater than 7, and then I have analyzed what is the differentiation of the function at that particular point. Okay. Now see the next one, for which values of a f of x equals to minus x cube plus 4a x square plus 2x minus 5 is decreasing for every x. Okay, ప్రతి ఒక్క x values కి for which values of a. Okay, so మళ్ళీ ఏం చేయండి, f dash of x is equals to minus 3x square plus 8a plus 2. సో ఇక్కడ చూస్తే వాల్యూస్ ఎలా ఉన్నాయి, minus 8ax. ఓకే, సో ఇక్కడ చూస్తే if you take the coefficient of x square, again it is less than 0. Okay, it is less than 0. So this value is less than 0. So you can see that the parabola is facing downward. So ఇక్కడ మీరు ఏం చేయండి అంటే మళ్ళీ b square minus 4ac, b square అంటే ఎంత, 8a whole square minus 4 minus of minus plus 4 into 3 into 2. So this should be less than 0. But let's just analyze this. 64a square plus 4 into 3 12, 12 into 2 24. ఏ ఒక్క వాల్యూ కైనా కానీ ఏ ప్లేస్లో మనం సబ్స్టిట్యూట్ చేసినప్పుడు a square will always turn out to be a positive value. Positive into positive, again positive value plus positive value, again a positive value. So there is no way that we can come up with any such value of a where this inequality holds, right? So such sort of an a you cannot find on a real number line, hence no value of a. అర్థమైంది కదా. సో ఎవ్రీ సింగిల్ టైమ్ జస్ట్ ట్రై టు సీ ద కోఎఫిషియంట్ ఆఫ్ ఎక్స్ స్క్వేర్ ఇర్రెస్పెక్టివ్ ఆఫ్ వాట్ ఎవర్ ద ప్రాబ్లమ్ డిమాండ్స్, దెన్ యూ జస్ట్ ట్రై టు కీప్ దిస్ బీ స్క్వేర్ మైనస్ 4ac ఈస్ లెస్ దాన్ 0. ఓకే, ఈ లెస్ దాన్ 0 ఎందుకు అంటే ఇట్ డస్ నాట్ స్లైసెస్ దట్ x-axis, it does not passes through x-axis. If it is passing through x-axis, there is a possibility that the graph is jumping to the positive values of y. Okay, so which we don't want, right? We want all the values to be less than or equal to 0. So that is all the whole thing is. Next, the value of k for which the functional value f of x equals to k times x plus sin x plus k is increasing is equal to. Similar ga malli video emantunnadu, it's an increasing function. So f dash of x equals to, what is the differentiation of this? K times 1 plus cos x, right? Plus differentiation of k is again equal to 0. So he's saying this value should be less than 0. This value should be less than 0. Sorry, this value should be greater than 0 because it is strictly increasing function. So for what values of k? So if you see, the cos x values are always lying between -1 and +1. Okay, it is always lying between -1 and +1, right? So the maximum value that this cos x could occur is 1 or it is 0, right? So 1 plus cos x values always lie between which two values? It lies between 0 and 1, right? It cannot just go apart, like it cannot go far from 1, like it cannot cross 1 or it cannot cross 0, right? But so the deciding factor is what? K. Only if this k fellow is greater than 0, that will be a strictly increasing function. If it is less than 0, it will be strictly decreasing function. Here we want it to be increasing function, so hence k should be equal to 0 because it is the deciding parameter out of the whole case. Okay. Now f of x equals to 2k plus 1 into x minus k into e power x minus x. So whatever is the function, it is strictly increasing. Again, take f dash of x is greater than 0. So what will happen if you try to differentiate this 2k plus 1 into differentiation of x is 1, the constant is 0, minus k into e power minus x, differentiation of this is minus e power minus x. So this will become plus k times of e power minus x plus 2 e power x, right? So which should be greater than 0 because it is monotonically, you can take equal to 0 in fact. So what can you take common? 2k plus 1, and here you can take 2k plus 1 into k by e power x plus 2 e power x is greater than or equal to 0. So just take 2k plus 1 plus k by e power x plus 1, this will be 1 plus 2 e power x is greater than 0, right? So now you can write this as k times of 2 e power x plus 1. Okay, from here you can write, ikkadi nunchi meer em rayochu ante, you can pull out the k and write it as 2 e power x plus 1 by e power x. Okay, so k into 2 e power x plus 1 by e power x plus, we have 1 plus 2 e power x, 1 plus 2 e power x. So what can you take common in these two? Now you can take 1 plus 2 e power x common. So 1 plus 2 e power x common, 1 plus 2 e power x common. So I am left out with k by e power x plus 1, k by e power x plus 1. Okay, so this should be greater than 0. Okay, you can take greater than or equal to 0. So 1 plus 2 e power x, k plus e power x by e power x. So this should be greater than 0. Now if you see here, if you try to completely analyze this 1 plus 2 e power x value is always greater than or equal to 0. Okay, so it always, the values, the range of e power x are tending from 0 to infinity. Okay, so this has no problem with us. So the left out is k plus e power x. So k plus e power x should be greater than 0, right? So that means from here he's asking then the least value of k. So what adugutundi ante minimum value of k where this inequality holds. Okay, so e power x values are always lying between 0 to infinity, so that is not a problem. The only way that this inequality sustains is only by having this minimum value. What is the minimum value where the k can hold in order to, you know, follow this inequality is k should take equal to 0, because if it takes -1 plus any sort of a decimal value will still sustain to be negative value where this inequality might not hold. That is the reason the minimum value it can take is k is equals to 0, because all the other values, the least value, even the 1 kuda satisfy aitundi, kani what is the least possible value he's asking? So the factor is the least one. Okay, if he asks if he would be asking what are the possible values where this where the function would be increasing, then we could have chosen MSQ, that is multiple selective question, either 1 or 0, right? But that is not the case. Okay, so only value is 0. Okay, so the similar thing again here I would like to just give the hint. ఒక్కటి ఏంటంటే, if you try to differentiate this function f dash of x equals to 3x square plus 2ax plus b, if you derive this function 5 sin square x, that will be 2 sin x cos x, so that will become again 5 sin 2x. Now if you try to see here, if you try to derive this function, I got this finally. So if you see here, this function sin 2x, it always lies between -1 and +1. Okay, it lies between -1 and +1. So if you try to take the discriminant here, so let's try to first analyze. So the least value that it can actually take is -1. So we'll try to redefine this by taking sin 2x value as -1, and now you try to take the discriminant for this, right? So 3x square plus 2ax plus 5, okay, you can take minus 5b, okay, 3x square plus 2ax minus 5b. Now you try to take b square minus 4ac less than 0 and try to evaluate among this there would be one option, okay. So I would like to go for the last question. ఇక్కడ చూడండి 1/2 mod sin x plus sin x, then f is, he's asking increasing, decreasing, increasing, decreasing. Now let's try to completely analyze this function. Mod sin x, okay, if you see mod sin x, ఈ ఫంక్షన్ ఎలా ఫంక్షన్ అవుతుంది? సో ఫర్ ద వాల్యూస్ ఆఫ్ x from 0 less than x less than pi, in fact pi వరకు అన్ని సైన్ వాల్యూస్ పాజిటివ్ ఉన్నాయి. Okay, so this is plus sin x. From pi less than x less than 2 pi, these values are minus sin x. Okay, now you try to analyze from 0 less than x less than pi. Ikkada the values are, so this will become from 0 to pi. From 0 to pi, the values, this becomes 1/2, this becomes positive sin x, 2 sin x by x, so that will become sin x. Okay, so from the value 0 to pi, this just becomes sin x. Okay, now you try to analyze in this case from 0 to pi. Now you analyze this function, just this function, sin x value. From which value to which value it will be positive, from which value to which value it will be negative. Okay, so if you see here from 0 to pi, it will be from 0 to pi by 2, it will be increasing, and from pi by 2 to pi it will be decreasing, because how is the sin x graph? We have sin x graph like this, where from 0 to pi by 2 it is increasing, from pi by 2 to pi it is decreasing, right? So we have the answer to be option C. Okay, so here comes the end of the session. So ఇప్పటి వరకు మనం డిస్కస్ చేసుకున్న ప్రాబ్లమ్స్ ఇవి. సో దీంట్లో I have left 1 or 2 problems for you, so please solve those problems. And మీకు ఏమైనా డౌట్స్ ఉంటే ప్లీజ్ డూ కమెంట్, అండ్ ఆల్సో ప్లీజ్ డూ షేర్, లైక్ అండ్ సబ్స్క్రైబ్ టు అవర్ యూట్యూబ్ ఛానల్. ఆల్సో దెర్ ఇస్ ఎనార్మస్ అమౌంట్ ఆఫ్ information and content that is available on our app also. Please download our app on Play Store, Sysya on Play Store, and thank you so much.